Now, the rest of the talk is going to be about the plot and the chart widgets. Now, the chart widget was around since the beginning of release 8.1, and the plot widget was added as a patch to 8.1, and they're both, of course, in 8.2, but it's not clear to me they've got enough promotion before, so we thought we'd talk about them. Both of them are very powerful, and in Lisp, very powerful means there are lots of options. And lots of options often looks like the facilities are complicated to use. But in fact, it's quite easy to get started, and then once you have a graph or a chart showing roughly what you want, then you just have to figure out how to tweak it in order to get exactly what you want. So let's start with the plot widget, and we're going to do a really simple plot. We have a variable which is a list of pairs, x running from 0 to 360 in tens, and y is the sign of x using the, we have to convert x's in degrees, so we convert it to radians by multiplying by pi and dividing by 180, and so y is the sine of the angle x. And we define a plot widget with this fairly simple definition here, only specifying a few arguments of the keyword arguments, which are specifying the details of the plot widget. The first argument here is just, this is a call to make instance, and it says make an instance of the plot widget. We're specifying the title, the width, and the height. And then we draw points on this graph with a do times loop running, or it could be a do list loop, but as you will see, it's a do times loop running through set plot value. And the result of this is that it prints the sine curve. And the point of this is that all we did was create a plot widget, specify a size, and plot some data. And there you go, you had a plot. And the defaults provided 2 levels of axis markings. It provided the points that were part of the data set and the connecting lines. And then if you want things to look different, you find examples that have the features that you want, and then you figure out what additional arguments you have to add. Now let's go look at this in the Lisp code. So here is the code for this. The first thing is simply setting up the value of synevals, and then here is the code that produces the dialog. The plot widget is created with these lines of code here. Here's the call to make instance. We specify a title. We specify left, top, width, and height. The width and height are 400 and 500. We also, a widget has to be displayed on a dialog, so we've also created a dialog here, and now this do times loop here is setting the plot value. And again, this is quite easy. Set the plot value of our variable, of our plot widget, which is the value of this local variable plot widget, and you just specify the x and the y. And I'm just running through the list, taking the first coordinate, which is x, and the second coordinate, which is y. So this is the function run to. Let's see. I think I have to do, if I can get the cursor in the right place. There we go. Run 1 simply creates the list of values, and there we are, 0, 0, 10, 0.173, etc. And run 2 creates our dialog. And never quite understand why you get that rather annoying warning, which doesn't seem to be related to what we're doing. But let me just do that again. Yes, there we go. So here is our plot, and again, my point is that a good deal of the information you wanted was provided automatically. The only thing you might want to change is that in the default it likes to pick round numbers to specify for the limits of the axes, and so our data only ran through 360, which is all the way around a circle, but it said 360. Well, it's a nicer round number is 400, so it actually ran the data out to 400. You could, if you wanted the graph to continue, just put in a few extra points in the data, or you could specify an argument that says I really want the right hand, the x-axis, just to run to 360, and then it would be back here. But again, the point is this is a very, very simple specification of the plot widget, and you get a quite nice graph without having to know too many of the features. So here are some more examples of plot widgets. These are from the documentation page for the plot widget. And I just wanted to show several features. The two things I wanted to point out is we're not talking about functions here. This thing isn't just graphing functions, it's graphing any set of XY points, and it connects them with lines. The lines are connecting from one point to the next if you want, and it can graph more than one data set, as is done here. And when there's more than one data set, it provides a little legend down here where you've specified the details of the description of what the data is indicating. This one's interesting. We'll get back to this briefly in that it has lots of labels all over it. We're going to talk more about how to produce those. And it also has two sets of axes. Here is the normal y-axis and x-axis, and here's an additional y-axis and additional x-axis. And the point of this is you can have your data plotted on different scales. The green data is being plotted according to these two axes. Now the top and bottom are actually the same in terms of the values. They both run from 0 to 10, but the y-axes are actually different. This one runs from 0 to 8, and this one runs from 3 to 7. Now the reason this is useful is that often that you want to plot two lines and demonstrate that two values such as weight and height or something are correlated, but the height is running from 40 to 80 inches and the weight is running from 90 to 210 pounds or something. They're completely different scales, but if you adjust them correctly, maybe you can show a correlation. But it's useful to be able to plot things and show your users the plot values. So this is why this is a nice feature. This one on the right, I just wanted to point out, you don't have to connect lines. This is just a pure scatter plot, as it's called, where you just plot points. Again, we have a legend down here that explains the blue squares are the first collection and the green circles are the second collection. And again, this is a common type of graph to make, and all that changed is that there's a draw lines feature, and it defaults to true, which is why we got lines in this case, and lines in our sign plot. Particularly, we didn't say anything about lines, and so they get drawn, but it is possible to specify draw lines to be nil, and then you get a scatter plot. Now, we're going to talk somewhat about the chart widget, and the chart widget and the plot widget share quite a few properties, but particularly those having to do with labeling and those associated with specifying the axes, particularly the vertical axis is the same in both cases. Here are three examples of chart widgets. Here is a simple bar graph where there are dates of events. Presumably, this is a bowling scores example, dates of bowling games, and we have 4 players, Doris, Hubert, Tal, and Myrtle, and only Doris and Tal played on December 12th. Hubert joined them on February 3rd. Everybody played on February 18th. Then Hubert dropped out, and finally Doris dropped out. And here are the scores for each player on these particular days. Now, this is showing this data as a bar graph, but here is the same data displayed with lines. It's got just the points, and then it connects the points with lines, so you get some of the, you can see more clearly the trend, as do, it's not all that easy to see how much of a change there was among these different bars, but it's made much clearer here. So that's the way you want to display the data. Also notice that the specification of the axes was actually just left to the default, and when you produce a bar chart, it goes from 0 up to the value, the maximum, a reasonable maximum value, which again, it's picking a round number, which it can display as the top value. When you do this with just points and lines, it won't go from 0, but it will pick as the minimum Y value when you're using the default system, something appropriate to the minimum value that you see. And finally, here's a different feature over here. Here we have viewing 3 of these players as a team. We have their total score, and then the individual scores are shown in these 3, assuming the names are the same. Here's Doris, here's Tal, and here's Hubert, and here were their individual scores averaged. I think this example is over these various months. And I'll talk about the labels shortly. We're going to talk more about the details. The plot widget and the chart widget are similar, but the plot widget is designed for arbitrary XY data. The chart widget evenly spaces items on the x-axis. Now, you can use a chart widget for drawing a plot, but only when the x data is evenly spaced. Now, in our example with the sine curve, in fact, we did have evenly spaced x data, so we could have displayed that as a chart widget rather than a plot widget. But generally, when you have purely numeric traditional x-axis data on the x-axis, the plot widget is the better choice because it gives you more control. And if you get new data which doesn't happen to be evenly spaced, it will be handled correctly by the plot widget, and the chart widget just won't handle it correctly. In the chart widget, the x-axis data is more typically categorical than numeric. So you could have objects like people or countries or months and years, which are quasi-numeric, etc. The plot widget basically has numeric on both axes. So we're going to go over a few details that apply to the chart widget and the plot widget. The difference between setting the value and using a returner function, some discussion of the different views, some discussion of axes and how they get labeled, some discussion of the other labels that appear, and then we're going to finish telling you where the documentation is for these 2 widgets. The difference between set chart value and chart value returner, and also set plot value and plot value returner. You can specify values in a data structure and then have set chart value or set plot value use them. And that's what we did in that sine plot. So we just had a loop, and it went through all the values in our list of values, and it plotted them. But you can also define a function, which is the value of the chart value returner property or the plot value returner property, and that function will run through a series of values and you will get the y value by providing an x value. If using a returner function, you obviously have to specify items like the number, things like the number of items you want, and because it has no way of knowing how often to call the function here. So let's go back to Lisp and actually look at what we're doing here. So let me see. I want to view the editor, and here we are. So again, this is what we did before. We created a plot widget, we put it on a dialog, and then we drew these values here. But if we come down and look at this next variant of this, it looks very much the same, except we're creating the plot widget. It's got the same title, and now we're defining a plot value returner function. And it is a function. We're creating an anonymous lambda function here. It takes these arguments, many of which we ignore. The ones we're really paying attention to are the value index is the one that we're playing, and the value type. And so we're looking at the value type, and basically we're looking at x's and y's, and I'm specifying a value for x by extracting it from our list of x, y values for the sign and specifying a value for y. Now, here are the three new arguments you have to specify in this case. The plot value's minimum index is 0, and the plot value's maximum index is 1 minus the length of our list of data. And we also have to say that there's at least one chart object. And then it will run through this data from 0 up to the length, and there are 37 values here, and it will do those on this single chart object. We've specified no ID, so it's not going to print information about it. This is the function run3. And you may recognize this. It looks remarkably like what we had before. The advantage here is that the plot value returner is a function. Now, all we're doing is just extracting these values from the list, which is exactly what we did before. But we could actually have extracted the x value from the list and then done the work, which is way, way up here, of calculating the sign of it like this. Or we could specify any function we like here that's specifying an x and y value. So this is if you want to have a general plotting routine where you specify a function which will get used using a plot value returner argument rather than just setting the values is the way to go, and it allows you to dynamically change in the standard list fashion what you're doing in this case by simply having a function object being the argument there and then changing the function object as you want. In that case, you do have to specify a few more arguments to get a plot that shows anything. If we didn't specify those things, it just simply wouldn't plot anything because it doesn't quite know what to do. Now, the next topic we just wanted to cover is views, and basically views are telling the system what it is you want to display. So for charts, bar and line are two views, but they're also chart view objects. Bar chart view is if you have a chart view object, you can also have a bar chart view, and that's where you can have the property values are stacked being t, and that will produce that bar chart that we saw back here, where it takes the three values and adds them up rather than displaying them as separate charts. So we have another example. Here we have bar chart. This is one of those examples. Let's have a look at it. There, that's the one where we are creating lines with the points indicating the data and the lines connecting them. And if we look at the chart widget, it says chart view is a line. So I'm just going to grab this form here and bring it over here and just evaluate it directly. But I'm going to change line to bar. And that simple change produced the other example that I showed. So here the chart view is a bar, and here it is done as points and with lines connecting them. And that difference was made just by specifying bar or line as the value of the chart view argument to the make instance of creating the chart widget. So bar and line, and again, for the plot, again, you have a plot view object, and it has a draw lines argument, and the draw lines argument can be true or nil. It defaults to true, so when we plotted our sine curve, we got the lines connecting the points. For the scatter graph example I showed you, there were no lines because in that case the draw lines property was specified as nil. Now, we've been just using these defaults for displaying the axes, and the axes basically are showing what are called major ticks and minor ticks, and the major ticks are 300, 600, 900, and the minor ticks are the 100 increments between them. And down here, this is a chart, so the data are evenly spaced along the y-axis. It's only displaying January and April, and you're assuming this is going to be March, February, March, and then April's displayed, May and June. And if we look at the arguments in the sources for this, and that's one of the examples in the chart view documentation or the chart widget documentation, if we look at the examples, we see here's the item axis, and the label is month, and that's what it says over here, month, that's what that label is. And then it says there's an argument minor ticks per major tick 3 and draw minor labels nil. Therefore, we've said you want what the name is may not be entirely clear. It said you want 3 items, 1 major tick, then you'll have 2 minor. So what it's saying is the major is divided into blocks of 3. That's what that 3 indicated. And the major is one of them, and then the other ones are minor. And we said, don't label the minor ticks. That's what the nil means there. Similarly, the value axis, which is the y-axis, we've said the major tick increment will be 300, the range top and the range bottom. 0 to 900 here, by the way, is how you specify what you want the axis to go from and to if you don't want to just use the default. So this thing is just specifying the 300, 600, 900, and then the major tick increment is 300, and it provides the minor tick values, and it also draw minor labels. The minor labels are drawn because the default value of that argument is true, so it doesn't have to be specified. And if you change the minor ticks to major ticks to 1, it will then display all of the months because there are no minor ticks in that case. Anyway, let's talk about labels for a bit, and this particular example has lots of labels on it. It's got a title up here, which is different, by the way. This is the title of the window that is containing the widget, the dialog that's containing the widget. The widget itself is just in the interior. So this is the title of the widget, Doris and Hubert. And then there is the person who made this example didn't quite know what to say, so he says this pointless subtitle will wrap. Then we have labels on all the axes. Then we have another label here. Again, he didn't know what to say, so it says there's really no reason for this. And then we have this little box which is identifying, which is a legend for identifying the contents. And I just wanted to show you the bit of that code. Here's the title, Doris and Hubert, which appears at the top here. There's a subtitle argument, and notice it's a format statement with those little tildes, meaning that this should all be printed on one line. There's no format directive to say put in a carriage return or a line feed or a line break, but nonetheless it does the line breaks automatically when the text does not fit. There's a subtitle color, so the subtitle appears in red, and there's a footnote, and the footnote appears down here. So you have 3 fields where you can put text, and you can put the text you want in those. So you automatically have quite a few areas where you can put descriptive text, presumably if you have something to say. Notice, too, the axis labels and the multiple axes, that we have a left and lower axis, and we have a right and upper axis, and they show different values, and they can be colored to indicate which points should be used on which axis. And again, I'm not going to go through that in detail, but if you look at the example on the plot widget page, you can see the arguments that produce that effect. The last thing I was going to say is the chart widget and the plot widget pages are indicated here. Doc is the subdirectory if you've downloaded the documentation. There are lots of properties, and we'll look at the pages just briefly in a second. There are lots of properties for both of these widgets, many of them shared in common because the labeling and the axes are very similar in both the widgets. And there's also a much longer essay with many more worked out examples for the chart widget. And so let's just quickly, I did bring up the chart widget page. Where are we? Here we go. I'll just bring it up again quickly. And so here's the chart widget. Here's the plot widget page. You notice here there are the properties, and once you start getting into the properties, you find they have more because the values of some of these properties, let's just look at the plot view. The value is an instance of the plot view, and you can go there and study the various choices that you have there. And if we come down, one more. Come down all the way here. There are several examples. I can do it faster over here. And also, there is quite a long chart widget tutorial, cg-chart-widget.htm, which shows you how to do many things. Now notice it talks about graphing mathematical functions. Those are also better done on a plot widget, but this was written before the plot widget was made available. So that's all that we have in the presentation today.